everyone, this is Mrs. Locke, and this is 1.1 segment lengths and midpoints. Our essential question for today is how can you use tools of the trade or concepts to describe the construction of geometric figures? So this is a continuation of our last class notes, and today what I want you to be able to do is use tools of geometry, tools of the trade, or different concepts to be able to construct pieces of geometric figures. That's our goal for today. A construction is a geometric drawing that is an accurate representation of a figure without using measurements. In simpler terms, that means you're able to draw something that is exactly the same as a previous image without using measurements. You use different formulas, or you use specifically like a compass and different construction tools to draw that. First up is the segment addition postulate. According to the segment addition postulate, let A, B, and C be collinear points. And hopefully you remember that collinear points are points that are on the same line, collinear together on a line. If B is between A and C, then AB plus BC equals AC. So looking at this line segment, I should say, B is between A and C, okay? So AB plus BC together make AC, and that should make a lot of sense to most of you. That seems pretty common sense, okay? So that's the segment addition postulate, okay? And then what we're going to do now is we're going to use a compass and a straight edge to construct a segment whose length is AB plus CD. So if you have not bought your compass yet, you need to stop this video and go to the store and buy your compass, because you cannot do these problems without having a compass. The first step says to use a straight edge to draw a long line segment and label the endpoint X. And I've already done that for you on this example because I wanted to show you exactly what it should look like. So just draw a long line. Don't worry about how long it is, using your straight edge at an endpoint, and then label that endpoint X. And like I said, I've already done that part for you. The second step says to copy the given segment, open the compass the distance of the segment. And you can see on my screen, I already have the compass open to the length of AB. So it's already open. And I'm going to move my compass down to my long line. And I'm going to draw an arc. That's the third step. I did not adjust the compass. I just moved it down and I drew an arc, and this is my new endpoint. This is the endpoint of the piece I just drew, and it should be the same length as AB because I started on the endpoint and it was open to the distance, and I drew an arc. So I want to add another segment to that, so I'm going to repeat the process. I'm going to move my compass down to my new segment. I'm going to open up my compass, the distance of it. I'm going to move my compass down to the new endpoint, and again, I'm going to draw an arc. And when I put my endpoint, there you go. So I drew AB, and I drew CD. So together, this segment is the length of AB plus CD. And we will do many constructions in this class, so don't worry if you're unsure. Pause this video, rewatch it again, play around with it. But you definitely need to become comfortable and familiar with drawing using your compass. So let's do another example. This time we're going to construct a segment whose length is 2AB plus CD. Go ahead and pause this video, follow the steps on your notes, and see if you can construct a segment whose length is 2AB plus CD. First thing I'm going to do, hopefully you've paused this video and you have tried, is you need to draw your line. So I took my straight edge, I'm simply drawing a line. And that was not a perfectly straight line, but you get the point. There we go. Much better. Okay. And there's my end point. Let me move this back up here. Get that out of the way. Okay, that's out of the way. And label it X. There we go. So there's my long line. And looking back at our directions, it said I need 2 ABs and 1 CD. Okay? So I'm going to make it switch a different color. There we go. So you can see the compass is already open to AB. So I'm going to move it down to my endpoint. Draw my arc. There we go. Remember, I don't need just one of these. I need 2 of these. So I'm going to move my compass over. There's my, oh, that didn't show up very well. There's my endpoint. So I'm going to move my compass over to my new endpoint and draw my arc. So far we have AB twice, and now we need 1 of the CDs. So moving it over, there's my CD. My endpoint is right where the arc and the line intersect. Drawing my arc. And there we go. I have AB, AB, and CD. Okay? So that's my new line. I constructed a line that is the length of 2 AB and 1 CD. Again, watch this as many times as you need to until you get the hang of it, and we will do some of these in class as well. So this is one way that you can construct, you make a construction without using measures. We're also going to use the Pythagorean theorem to find the length of a segment on a coordinate plane. This is example 2. You see that I skipped over the distance formula in your notes. We'll go back to the distance formula in a few minutes. So using the Pythagorean theorem, I'm going to find the length of the segment. I want you to think about, what is the Pythagorean theorem? What is the formula for the Pythagorean theorem? Hopefully you said that the Pythagorean theorem in a right triangle, a squared plus b squared equals c squared. A squared plus b squared equals c squared. In a right triangle. So I'm going to take this this segment on the coordinate plane and make a right triangle out of it. There is 1 unit on the left side, the left leg, and 3 units on the bottom leg. So it doesn't matter which one is A and B. I normally call this one A and this one B, but the hypotenuse is always the C. So A squared is 1 squared. B squared is 3 squared equals C squared. 1 squared is 1 plus 3 squared is 9 equals C squared. What's 1 plus 9? 10 equals C squared. Now some of you may think, okay, I'm done. The length of the missing segment is 10, but that is not the case. Think about why that is not the case. I'm looking for C, and we found C squared. So how do I unsquare the C squared? Well, I'm going to apply the square root symbol. I'm going to take the square of it. So the square root of C squared is simply C. The square root symbol cancels out the squared sign, and the square root of 10 cannot be any simpler than the square root of 10 unless we use unless we use a decimal number. So C equals square root of 10. So JK, finding the length of the segment, is the square root of 10. Hopefully you're already familiar with the Pythagorean theorem, but we will definitely be using the Pythagorean more in geometry. I would, if you have a highlighter, highlight the phrase Pythagorean theorem. Let's see if I can easily highlight right now. Highlight, I don't know if it's going to let me highlight super well. Nope, that color's over it. Okay, but if you have a highlighter, go ahead and highlight Pythagorean theorem. There we go, I can change that. Haha. Highlight Pythagorean theorem, and I may highlight this formula as well. There we go. Okay? Because you're going to want to refer back to that in your notes throughout the course of geometry. Okay, you will see that in your notes, I skipped over the distance formula. And the distance formula is the distance between 2 points on the coordinate plane. And the formula for the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, I would take this and I would highlight this in your notes because we are going to refer back to this so many times and we're going to need the distance formula. You need to memorize that. We will be using it on quizzes and on tests. You'll be referring back to it all year long. I can guarantee you, you will need the distance formula knowledge for the rest of the year. Okay, so the distance formula is to find the length between 2 points. And so if I am looking for the length of, it's to find the distance between 2 points, the length of a segment, right? So, for example, we're on example 3. I can use the distance formula to determine whether the given segments have the same length. So the question is asking me, are A, B, and C, D the same length? Is this segment right here, AB, the same length as CD? And excuse the unstraight line. But a lot of you are probably thinking of, well, I'll just use my ruler to find out. Well, you're not always going to have a ruler on these tests. You have to be able to use different formulas to find the answer. And to determine the length of this, we can use the distance formula because the distance formula is the distance between 2 points. The distance between 2 points. And A and B, A is a point, B is a point, there's a distance between 2 points. So I'm going to find the distance first between A and B. So A and B. The coordinates for A are -4, 4. And the coordinates for B are 1, 2. Remember, the distance formula has an x2 and an x1 and a y2 and a y1. So I'm going to make this my first set of points and my second set of points. So the square root of x2, which is 1, minus -4 squared, plus y2, which is 2, minus 4 squared. Square root of 1 plus 4 squared plus 2 minus 4 is -2 squared. Square root of 1 plus 4 is 5 squared plus -2 squared is 4 because -2 squared is -2 times -2, which is 4. Square root of 5 squared is 25 plus 4 square root of 29. So AB is the square root of 29. And I cannot make the square root of 29 any simpler because 29 is a prime number. So now I have found the distance between A and B, or the length of AB. So now I need to find the length of CD. So I'm going to do the same process all over again. So I'm going to go ahead and erase this. And erase this. And do the same thing all over again. And scholars, my geometry scholars, even when I am solving problems like this, I still go the extra step and write points down. So for example, C is located at 2, 3, and D is located at 4, -2. And it's so important. This is going to be my first point, my second set of points, because I don't want to make any silly mistakes. And it's worth just taking the time and doing it right the first time. So the distance formula, the square root of x2, which is 4, minus x1, which is 2. Hopefully you're seeing where I'm getting this from. In a set of ordered pairs, it's x, comma, y. So these are so 2 and 4 are my x's, and 3 and 2 are my y. So this is my x2, my x1, my y2, and my y1. Okay, that's where I'm getting those from. Okay, so back to the formula, 4 minus 2 squared plus y2, which is -2, minus y1, which is 3. Squaring that as well. Square root of 4 minus 2 is 2 squared, plus negative 2 minus 3 is negative 5 squared. Square root of 4 plus 25, because 2 squared is 4, negative 5 squared is 25. The square root of 29. And you can see that CD is indeed the square root of 29. So, do AB and CD have the same length? Yes, they do. Okay? So, we're going to do the same process for EF and GH. I told you guys in class that this video would be a little longer because we are doing some math. And so, yes, indeed, you will have to actually work a few things out. We're going to do the same thing for EF and GH. So, I'm going to go ahead and... I need to keep this right about here so you guys can see this. I'm going to erase this because I need to use this as some writing space. Okay. So point E is at negative 3, 2, and F is at 1, 2, 3, negative 3, negative 3, negative 2. Yep, that's correct. E is going to be my first point, and F is going to be my second point. I want you to go ahead and pause this video and use the distance formula to find the distance from E to F. Sorry, guys, I wrote the points wrong for F. My apologies. Again, this is why I write them down, so hopefully I catch my mistakes. The coordinates for F are negative 2, negative 3. I switched my X and my Y. This is why it's so important to write stuff down and to double check. Okay, so now I want you to go ahead and find the distance between E and F. Okay, I worked this out, and you can see that the distance between E and F is the square root of 26. And that I cannot make that any simpler because the factors of 26 are 2 and 13. And those are both prime numbers, so I cannot make that any smaller. So the square root of 26 is the distance between E to F. So now we need to do the same process for GH. And you can take a minute and pause this video and check your work against mine and see if you did not get the square root of 26, why you did not get the square root of 26. And again, we will do problems like this in class where we are working out the distance formula, but it's simply a formula plugging in numbers. So double check, make sure you're putting in the right numbers, that you're multiplying correctly, and so on. So go ahead and do the same thing. We're going to do the same thing for GH, so I'm going to erase this. And we will find coordinates for G and H. So I'm going to look at that graph, see if you can figure out the coordinates for G before I write them down. Coordinates for G are negative 2, negative 4, and the coordinates for H are 2, 0. Okay, so we're going to use the distance formula again to find the length of GH. G will be our first set of coordinates, and H will be our second set of coordinates. Okay, I worked this out, and you can see, if you've looked at my problem, that I got the square root of 32, which is definitely different than the square root of 26. So GH is the square root of 32. And I actually can make that, I can factor that out a little bit. 16 is a perfect square, and 16 times 2 make 32. So I can make this as the square root of 16 times the square root of 2, and the square root of 16 is indeed 4. So 4 square root of 2 is what the square root of 32 can become. So you could also have written 4 square root of 32 if you are, not 32, 4 square root of 2. If you are very good with math and you figured that out already, props to you. 4 square root of 2. So to answer the question, are EF and GH the same length? And the answer would be no. We know they're not because EF is the square root of 26 and GH is the square root of 32 or 4 square root of 2. Again, no worries. If you did not get the same answer as me right away, this is brand new. What I do care about is that you're watching through this and trying your hardest to solve through the equation. Okay, moving on. How do you find the coordinates of the midpoint? The midpoint formula, yes, another formula that you need to memorize. Again, I would go ahead and highlight this nice and big in your notes so you can refer back to it. We need these formulas. They are super important. The midpoint of a line segment is the point that divides a segment into two segments that have the same length. Basically, a midpoint cuts something in half. If M is the midpoint of this line, then AM is the same length as BM. Okay? A midpoint cuts something in line. What does a segment bisector do? A segment bisector is a line, ray, or other figure that passes through the midpoint of a segment. So, for example, we know that we have M is the midpoint here, and line L passes through PQ. So line L is bisecting PQ, meaning it's cutting it in half. Okay? If I use the word bisect, that definitely means to cut two pieces in half. Bi is 2, so bisecting, cutting it in 2. The other thing I want to remind you of, and you do not have this on your notes, so maybe you want to draw it, a coordinate plane. We have the x-axis and we have the y-axis. I'm just drawing on top of this to make it a little bit more noticeable. It's in 4 quadrants. So here's the y-axis, here's the x-axis. Quadrant 1 is when both of the coordinates are positive, positive x, positive y. Quadrant 2 is a negative x and a positive y. Quadrant 3 is a negative x and a negative y. And quadrant 4 is a positive x and a negative y. And when naming them, if someone says quadrant 3 and you don't know which one they're talking about, we always start in the double positives and we move in a counterclockwise direction. So 1, 2, 3, and 4, a counterclockwise direction. Okay? You will need that for the problem we're about to solve. So it was not on your notes. I put it here if you want to add it to your notes, maybe down in the summary area. Last thing we're working out is show that the statement is true. If PQ has the endpoints P, -4, 1, and Q, 2, -3, then the midpoint M of PQ lies in quadrant 3. So we're trying to find out if the midpoint of PQ lies in quadrant 3. And this is quadrant 3, so we're going to find out if a point lies there. So they're asking us if the midpoint does. Well, we don't know what the midpoint does, but we have the formula for midpoint. x1 plus x2 divided by 2. y1 plus y2 divided by 2. So here's my 1s, here's my 2s. So x1, -4, plus x2, which is 2, divided by 2. What is -4 plus 2? 2 over 2. -4 plus 2 is -2 over 2, and the -2 over 2 becomes -1. So my the x-coordinate of my point, of my midpoint, is -1. So now let's find the y-coordinate. y1, which is 1, plus y2, which is -3, over 2. 1 plus -3 is -2 over 2, which also equals -1. So I just found the midpoint of PQ. It gave me 2 points. I found the middle of it. It's basically saying, here's P, here's Q, find the middle point. And so I use the coordinates of P and I use the coordinates of Q to find what the middle point would be. Okay, that's what we just did. So the question says, though, tell me if it's true. Does the midpoint lie in quadrant 3. So here is the midpoint, -1, -1. Is that in quadrant 3? And looking at our example, yes it is, because both the x and the y are negative. So the answer would be yes, it lies in quadrant 3. Moving on to our last example. If RS has endpoints 3, 5, and S is -3, -1, then the midpoint of RS lies on the y-axis. Okay, so we're looking to find, again, the midpoint. So you need to use the midpoint formula. This will be point 1, this will be point 2, and once we find the midpoint, we have to figure out, does it lie on the y-axis? Okay, so x1 is 3 plus x2 is -3 over 2. 3 plus -3 is 0 over 2, so my first point is 0. Okay, and my y is 5 plus -1 over 2. 5 plus -1 is 4 over 2, so it's 2. So my x is 0 and my y is 2. So be paying attention to what the question is asking. Most questions, like on the EOC, are not just going to say, find the midpoint. They're going to give you a word problem that's going to ask you to prove something, and through that, you will have to find the midpoint, like this. I talked about having endpoints, and it wanted us to prove if the midpoint was on the y-axis. So we had to use those endpoints to find the midpoint, and now once we found the midpoint, determine something about it. So let's plot 0, 2. So 0 on the x-axis is right here, 2 on the y-axis. Let's say it's right here. So this is point 0, 2. Would you agree that it's lying on the y-axis? Yes, it is. The point is lying right on the y-axis. So yes, this is true, or you could say yes, whatever you wrote down. Okay? Okay, that concludes this lesson. Make sure at the bottom of your notes you are writing a summary as a recap of what we went through today. We talked about different constructions. I wanted you to be able to use some tools of the trade and some formulas. So the first thing that we did was talk about the segment addition postulate, and then we used our compass to find the length of a couple of segments. We did that 2 times. We definitely will be getting more familiar with that. We also used the Pythagorean theorem, a squared plus b squared plus c squared, to find how long a line segment is. Then we moved on to the distance formula, and we found how long segments were and compared them. So the first thing we did was we had to find how long they were, and then we had to compare them together. And then after we did that, we used the midpoint formula to find the midpoint. So midpoint, and then we talked about quadrants. And then we use the midpoint formula to find the midpoint and then to determine something about the midpoint. So yes, it was in quadrant 3, and yes, it was on the y-axis. Please make sure you do your summary. If you have any questions, watch this video again. Watch just the parts of it that you need, and be prepared to talk about this on Tuesday morning or Tuesday afternoon in class. Have a great weekend, guys, and I'll see you then.